All right, here we go. This one's a touch trickier. Okay. An Among Us crew member and her friend push a heavy piano across the ground at a constant speed. Okay, so again, I'm looking for these words, constant speed, okay, and I'm going to see that the forces are balanced, okay? And hint, for this week at least and a little bit of next week, everything's going to be balanced, okay? So that we have to do like big ones for, okay? All right, so interaction diagrams, okay? So let's see, crew member, I can't spell, whatever, okay? Friend, piano, ground, and earth. Okay, so this is a trickier one because there's going to have to be 3 force diagrams we're going to make this time. Okay, right? Okay, and the crew member and the friend are not touching. Okay, so I'll make a little note of that somewhere, right? Crew member and friend are not touching. Crew, friend, not touching. It was hard to kind of make the picture. Okay, so yeah. All right. Okay, so let's see. So let's think traditionally how we would look, right? We would say, oh, the crew member and the friend are pushing the piano. Okay, so that's a push. So the friend and the piano are going to have a normal, and the crew member and the friend are going to have a normal. The crew member and the piano are going to have a normal. Okay, all right. The crew member and the friend are not touching, so they don't get one. Okay, and there's no friction either, right? Because where their hands are pushing, there's no relative sliding, okay? It's just a straight compression push. There's no sliding happening there, okay? So that's just going to be a normal, okay? All right, everything with the earth, with the ground, piano and ground is going to have a normal, and there is relative motion, so that's going to have a friction, okay? The friend and the ground, also a normal and a friction. Anybody that's walking has a friction, okay? Because you have to, because if you don't have friction, you're not walking. You have to grip that ground in order for the ground to push you forward, okay? Same thing with the crew member and the ground. They're also having a normal. He's also having a normal and a friction, okay? All right, and then everybody's going to get one with the earth. And the ground if you want. Oh, shoot, this is going to get all tangled up. Ugh. Friend and gravity, and then crew member and gravity. Boom. Okay? All right. So this is going to get a little trickier. Okay, so let's look at the friend. Okay, so this is going to be the force diagram of the friend, the force diagram of the crew member, and the force diagram of the piano. Okay? It's probably a little easier to do the piano first, I think, but you don't have to, okay? So let's do piano first, all right? So, well, let's see how many it has first. Okay, piano has 1, 2, 3, 4, 5 interactions. Okay, so the piano's going to have 5 interactions. So let's do force of gravity first. Okay, force, gravity, piano, earth. Okay, so that's that one. Okay, the piano and the ground is going to have a normal, right? So that's a surface force. Force, normal, piano, ground. Okay, now we have to worry about these left and right ones, okay? So the piano is going to have its own friction, right? Because it's probably like sliding against the ground, okay? And both of the guys are pushing, all right? So which direction are the crew member and the friend pushing? And that would be to the right, okay? Because the piano feels it to the right, and they're both pushing the same way, okay? So this is going to be force, normal, piano, friend, okay? And force, normal, piano, crew member. All right, and they're both pushing to the right, so both of those arrows are going to point the same direction, okay? And since the forces are balanced, there has to be enough friction, right? So it's going to have to be bigger, right, to encompass both of those for it to move at a constant speed. Okay, so force, friction, piano, ground. All right. Okay, let's look at the crew member. 1, 2, 3, 4 interactions for the crew member. Okay, so we'll start with gravity. Force, gravity, crew member, earth. Okay, so that's that one. All right, and then normal with the ground. Right, so force, normal, crew member, ground. Okay, all right, now here's where it gets a touch tricky, right? The crew member and the piano are having this normal interaction, Okay, so remember, the diagram is what it feels, not what it does. Okay, yes, the crew member is pushing the piano to the right, but that's what the piano feels. We need to know what the crew member feels. Okay, so when that piano is being pushed to the right, the piano is pushing back on the crew member to the left. Okay, so force, normal, crew member, piano. Okay, and then what I can do is I can see, look, that's going to be my pair. Boom. Okay, do you see? Force, normal, crew member, piano, force, normal, piano, crew member. Okay, if you circle the Newton's third law pair and they're facing the same direction, that is wrong. They have to be facing opposite. Okay, and then since it's moving at a constant speed, the forces are balanced. There has to be a force this way to balance out that normal force, and that has to be the friction of his shoes on the ground, or her shoes on the ground. Force, friction, crew member, ground. Okay, anybody that's walking is going to have that forward-facing friction because you have to, or else you can't walk. All right, okay, and then the last one is going to be of the friend. 1, 2, 3, 4 forces on the friend also. We'll start with the friend's gravity. Okay, friend earth. And the normal force from the floor, force normal, friend ground. Okay, and please make sure you're using the letters I specify, okay, so it doesn't get confusing. Okay, all right, same thing with the friend, right? The friend pushes the piano to the right, so the piano pushes the friend to the left. All right, so the friend is going to have force normal, friend piano. Okay, and again, do you see that is my third law pair with that? Okay, force normal, friend piano, force normal, piano, friend. They'll be opposites. Okay, same thing because these guys are facing the same way. This guy's also going to need a friction on his shoes. So force, friction, friend, ground, facing to the right. Okay, so since there's 3 diagrams, we can have 2 Newton's third law pairs, right? Because you can have one, right? Remember, we're comparing the feeler. So we have the FP one, my pencil's dead again, and the CP one. Okay, all right. So hopefully that was fine and you got all that. And then if you already came to class, then you can go ahead and try these, which are the same but with numbers. Okay, and if you have not yet come to class, you could try these if you want, but it will be a little easier after you do the face-to-face stuff in class. Okay, so your call. If you feel like you're super confident, you could probably move on. If you're feeling a little shaky, make sure you do the in-person stuff first before these. Okay, but if you're feeling super golden about it, then you can go ahead.